for today. My hope is that by the end of this presentation, we'll have provided answers to some of the bigger questions regarding the reusable tools and modules in PCORnet. We're going to start by covering why we develop and prefer reusable tools in PCORnet, and then we'll move on to what tools are currently available in our toolbox. This section will include basic overview of the available programs, but we're going to also have a spotlight section on one of our newest modules, the Cohort Quality Assessment, or CQA, optional program add-on. After that, we'll cover where we're going next with tool development, and I'll then pass off to Shema, who will briefly discuss how we're working to track program efficiency and make determinations about runtime and package size thresholds. Finally, we'll get to talk with some of the people with whom we work to test the program packages before they're released to the network. Reusable tools refer to any of the parameterized programs we use to answer standard PCORnet requests. These were developed to answer recurring health research questions in a reusable and efficient manner while maintaining patient privacy and meeting the minimum necessary requirements. PCORnet's reliance on a common data model requires that sites transform their local data into uniform tables and with standardized variables and fields. That standardization allows us to use the same program at all participating data marts and prevents the need to translate each individual request to fit the specific architecture of the local EHR or claims systems. All reusable programs are also defensively coded to account for the many variations in local infrastructure that may impact execution. When we talk about the parameterization of PCORnet tools, you may often hear us refer to them as similar to a Mad Lib. With Mad Libs, users are asked to sub in nouns, adjectives, etc. Of their choice in order to form their own story. A similar approach is taken with our tools. Researchers can sub in various exposures or outcomes of interest, demographic criteria such as age, race, sex, etc., time periods of interest, and then they'll eventually form a cohort that tells some type of healthcare story. There's several benefits to our use of reusable programs to answer research questions in PCORnet. Most obviously, the existence of a pre-developed program leads to quicker assembly and release time whenever the network receives a new research question that fits into these predefined template models. Recurrent use of these tools also contributes to network-wide familiarization with querying processes. The query fulfillment or QF team analysts become comfortable with package assembly and testing, which allows for quicker time to release once all parameters and code lists have been provided by the requester. Data partners become familiar with required program execution steps and standardized output. They know where to look if they want to determine whether the program ran without error or if they want to compare their final cohort population against internal explorations of their data. Continued use of the tool also benefits both QF and the data partners in that it allows us to identify common execution issues and troubleshooting options. On this slide, we have a high-level description of the tool development process. We work in development cycles with series of major and minor releases, but all of those releases first follow this general flow. You'll note that many of the steps are iterative. Discoveries made in one step may require updates to earlier components. We test extensively, both internally and externally, which can identify bugs or opportunities for efficiency updates prior to network-wide release. I want to particularly emphasize the importance of that beta testing step on this slide. At this step, the program is distributed to several data marts with differing sizes and infrastructures. This allows us to assess scalability of the programs, but is also useful in that we can identify program bugs that may only be able to be picked up on a larger scale. The overall process aims to optimize PCORnet querying for multiple stakeholders. We try to meet requester needs by speccing out new tool functionality on a frequent basis. We work with data marts to identify areas for improvement from a site execution and review standpoint. And the robust testing process is aimed at making things easier for both us and the sites, and that we're able to limit the amount of troubleshooting and re-executions that are necessary for a given request. This next slide breaks down the 5 major development cycles of the PCORnet modular programs from the past 2 years. As noted, numerous stakeholders can contribute to the various updates and releases of these programs. For example, the development of the RTF report stemmed from a data mart working group that highlighted the need for easier review processes in order to meet query turnaround time. The initial PMP2 release stemmed from a requester's desire to query medications using PCORnet's dispensing and prescribing tables. We also actively maintain a wish list of new functionalities or improvements that have been requested from any of our stakeholders or identified internally, and we examine this frequently for potential for incorporation of these wish list items into each development cycle. So now that we've covered why we use reusable tools, I want to spend a little bit of time doing a brief overview of those tools and how they've evolved over time. I know that some of the writing on these infographics can be a little bit difficult to read, so we'll certainly make these slides available for further use afterwards. But we can focus really just on the main infographic portion. Data partners may remember the first modular program release back in 2016, which used PCORnet Modular Program 1, or PMP1. PMP1's architecture was leveraged from tools designed by the FDA Sentinel system. In converting the program from Sentinel, various PCORnet-specific considerations had to be kept in mind, such as the transition away from claims or insurance-based enrollment definition towards an encounter-based enrollment definition, which is more in line with the EHR data that PCORnet uses. Multiple queries went out using PMP1, but over time the network received increased requests that wanted to make use of the prescribing and dispensing information captured by the data model. PMP1 was subsequently updated to allow for querying based on the presence of a medication and became known as PMP2. A subsequent PMP2 release also leveraged a reusable module developed for the obesity demonstration projects that allowed for characterization of the cohort formed during PMP2 execution. As I mentioned before, I'm not going to spend too much time on cohort quality assessment here because we'll cover that in a bit more depth later. Not specifically highlighted here, but PMP2 releases also included fairly significant updates to the way that inclusion and exclusion criteria can be defined in a cohort. And we also incorporated the ability to identify a difference cohort, which is oftentimes referred to as the unexposed group. And then finally, we have the latest release, PMP3, which was first distributed to data partners at the end of May. This program incorporates the ability to look for presence of a lab record to define a cohort, while maintaining all previous functionality from the earlier programs. It also incorporates CDM v4 compatibility, which will make the summer transition to the newest CDM version a bit smoother. We've also noted improved reporting capabilities in the bullets here. That's actually been expanded on in multiple areas. So it includes updates both to the RTF report, which summarizes PMP cohort formation, and to the PDF report that is generated by cohort quality assessment if requested. Internally, this development cycle also generated a by data mart reporting mechanism that allows for faster turnaround of final reports for the requesters once all site data has been returned. We'd originally been working with an aggregation program that allows us to rapidly combine results for all responding sites. However, there's been an increased frequency of reports requesting data mart specific counts as well. So this new report program allows us to generate both aggregate and individual level reports with rapid turnaround time. This chart helps to break down the evolution of our tools from PMP1 through PMP3. As noted by the arrow, each major program release has added complexity, but we've also really tried to make sure that with each release, we're also making an effort to improve efficiency as well. I don't want to spend too much time on this chart because there's obviously quite a bit of information in there, and again, these slides will be made available for people that want to look into the details a bit further. But I'd like to highlight the optional programs line at the bottom and the development of cohort quality assessment, or CQA, which was first introduced in PMP2 and has since seen some updates in our recent release of PMP3. We wanted to spend some time highlighting CQA because for the sites that didn't participate in the obesity demonstration projects, I think that this module may still be a bit of an enigma. CQA is an optional module that can be run alongside a PMP2 or PMP3 defined cohort to perform cohort-specific data quality assessments and characterizations. The concept of CQA was originally spec'd out for the obesity studies, since they'd be relying on information from the labs and prescribing tables, which to that point hadn't been explored in depth. However, early in the development process for the two studies, it became pretty evident that the ability to grab summary statistics and basic characterizations of study-related variables amongst a cohort could be of high value in the future. So rather than hard code the bariatric or antibiotic study variables of interest, we worked with our programmers to develop a parameterized input-driven program that could generate summary statistics for any given variable in the PCORnet data model, if requested. This diagram depicts the various required inputs and outputs of the CQA module. Using input files, you're able to indicate which cohorts require additional characterization, which tables and variables are of interest to your particular study, and if applicable, whether you'd like to limit assessments to codes of interest. CQA will process those various inputs, perform the requested checks, and output separate files for frequencies, counts, and distributions. As integrated into PMP2 and PMP3, CQA is able to be performed against either the numerator cohorts or the unexposed cohorts. I wanted to spend a brief moment just to call attention to the difference between the DRNOC's data curation process compared to cohort quality assessment. Data curation is a vital quality control process that performs checks against the entire population at a given data mart. However, there's certain checks that may not ring any alarms in the population as a whole, but would be concerning if you were looking at a particular cohort that you're hoping to study. The way the CQA module will work is it will limit all checks to the cohort group that was originally formed by your PMP program. Quality assessments will, in effect, be limited to the group you actually care to use in your eventual study. A good application of the difference between data curation and CQA would be a check to assess the percentage of your population that had received an HbA1c lab in the previous year. In the population as a whole, you may see a fairly low percentage of individuals with evidence of that particular lab. However, this wouldn't be particularly concerning. However, if you first formed a cohort of individuals with a diagnosis code for diabetes, and then assessed the percentage of that particular group with an HbA1c lab in the previous year, you would expect to see a much higher result. Similarly, you might expect that the lab result distributions would differ substantially for A1C labs performed against the general population versus those performed against a cohort with known diabetes diagnoses. This slide uses the bariatric study example for why cohort-specific characterization and quality assessment was necessary. BMI distributions against the general population may reflect something along the lines of national averages, but that wasn't the group that the bariatric study was interested in looking at. Amongst a cohort that had received bariatric surgery in the following year, you would expect a sharp divergence in BMI distribution. Missing this assessments can also be of particular interest to the studies. Requesters may not care about data completeness for the overall population, but if certain variables are not well populated for their cohort, this may be of more concern. For both of the obesity studies, results of these cohort-specific quality assessments allowed the team to make important eligibility decisions, but perhaps more importantly, it also allowed them to begin conversations with sites about the reasons behind some of these data anomalies and how these might be corrected. This slide just has a little bit of information to note that the optional CQA module has its own reporting tools built into the PMP programs. The programs will automatically generate a formatted PDF report for each cohort that undergoes quality assessment. The report will contain only the quality assessment statistics that were specifically requested in those input files we covered earlier. Because CQA is typically used to identify site-specific data issues or eligibility criteria, the output and reports will typically be viewed individually. But we also have a local aggregation program that will allow us to view certain checks overall if it's necessary to compare an individual site against the overall trend. And this slide just has a few screenshots of what some of those output tables might look like in the PDF report. They were all generated using fake data, so the counts are understandably quite low. So finally, before passing it off to Shema for our runtime discussion, I wanted to spend a quick moment discussing where we go next with tool development. The bullets here contain a pretty basic breakdown of some of our major upcoming development goals. So number one is the incorporation of a Table 1 or baseline covariates table module. This will be incorporated similarly to CQA as an optional program module that can run against a given cohort. The table will allow for rapid cohort description by baseline covariate profile as well as Charlson comorbidity index scores. This development is currently in progress and release is anticipated by the end of summer. Another major development goal in the near future includes the ability to define or characterize cohorts based on specific vital measure criteria. These updates are currently in the discussion and architecture phase, so be on the lookout for those coming soon. And then finally, we have a bullet for efficiency updates. This is something that is really continually on the minds of our development team and our programming team. We recognize that execution of these complex programs take time, and as such, we're really constantly searching for areas where efficiency can be improved. We recently developed a runtime tracking mechanism that Shane is going to cover in a bit of further detail, but this allows us to monitor program execution, again, across different packages and program versions. Moving forward, this tracker is going to be essential in that it will, one, help us determine the efficacy and impact of some of those programming changes aimed at increasing efficiency that are incorporated into different program package releases. We'll be able to use that to determine if those changes had a significant effect on improving runtimes. And then it will also help us determine if there are specific package size or complexity thresholds that could maybe impact sites' ability to respond by query deadlines. So with that, I am going to pass things over to Shema so she can give a bit more detail on the runtime tracker.
Thank you, Casey, for providing such good insight into the tool development process. I'm going to switch gears a little bit and discuss our new runtime tracker. So as we continued to develop our tools, we needed a method to examine runtimes. So we developed an automated program to extract these times for each query. During report generation for query results for the requester, the runtime is additively included into a tracker. This allows us to see improvements in program efficiency over time, as well as examine the program package and complexity thresholds. So where do we find the runtime? Now I recognize this might get a little technical, and I want to point out where we're pulling this data from. So when data marts submit their query results, a SAS output table is generated called a signature file, which you can see here. As can be seen, this file contains runtimes as well as other query details. For our purposes, we actually use the seconds variable and convert into minutes or hours. This table outlines the mean and median runtimes for the past 9 queries that have been released into the network. I will be referencing this slide throughout the presentation and would like to point out a few items. The table includes an estimate of query complexity. This measure is based on knowledge of the tool, the data being used to answer the question, query count, as well as query logic. On average, we also get around 60 respondents for each query. This is a histogram representation of the previous table, plotting the mean and median runtimes by query. The green bars represent mean time in hours, while the blue bars represent the median runtime in hours. Now, the very first query represented on this histogram was run on PMP2 version 2.0, while the rest of the queries were run on PMP2 version 2.1. You can see the dramatic drop in both mean and median times between the two packages. Now, we plan on continuing to track efficiencies with all future developments as we move forward. Now, what if we were to hold the program package constant? All of these queries were run on PMP2 version 2.1. I mentioned earlier the idea of query complexity, which takes into account the tool being used, knowledge of the data, query count, and query logic. The set of peaks highlighted here point to a query that had a higher query count and complex query logic. We predicted it would have an increased processing time. To help combat this, we grouped the query logic in a way that made the most sense based on the data being used and the parameters, and we're able to keep mean times under 10 hours for all groups. I would also like to highlight 2 more queries of differing complexities. we're going to start with the insomnia medication query, which had a query complexity of low to medium. This plot depicts the responding data mart's size versus runtime. Now we can see that even some of the largest data marts were able to run this program package in a little over 10 hours. Now, what if we were to take a look at a more complex query, such as the cardiovascular working group query, which was ranked as a complexity of medium to high? We knew this query was going to be more complex due purely to the fact of query logic, so we wanted to account for that in program efficiency, so we actually grouped this query into two different groups, and we're able to see that responding sites were able to run the package within 15 hours for both packages, for both groups. So how do we plan on using this information in the future? Our team will use this to evaluate improvements in future tool development, and we also plan on sharing the initial runtimes and runtimes for previous queries when we release new queries into the network. So we'll be able to tell data marts, during initial rollout, this query took X number of hours, so you can prepare your own when you want to run the query and if you're going to respond, as well as telling people that, we've had a previous package that was about this size and it took this long to run as well. So it'll help inform query design as well as balance for query complexity. I would like to thank the rest of the Query Fulfillment and SaaS Analytic team for helping with all of the developments that we've presented today. We're going to switch gears into the beta tester discussion panel.
Great. Thanks so much, Shema. So Shema and Casey, really helpful presentation. And at this point, we'd really like to open it up to a couple of our beta test experts, people who have participated in the beta test process for various reusable tools that we've tested in the network. And guided by a couple questions, which we'll show next, we'll be able to get some input on both how things have been running and how we can improve things in the future. So Elizabeth, Lindsay, Susan, and Robert, you should be unmuted. And I'll just mention also that we will address the questions in the chat box. I appreciate everybody putting their thoughts and questions in there. And please do, if you have any other questions, respond to everyone using the WebEx chat. So for the first discussion question, and we'll just go in order of whoever feels like they are ready to answer the question, we're going to discuss how the evolution of PCORnet tools has impacted your site. Would somebody like to provide some input on this?
Sure. This is Robert Bradford from UNC. Early on with the PMP,